Rock Duck. So in 1969, NASA sent the Apollo 12 lunar module to the moon, and the ascent stage crashed on the moon by design, and the reverberations and echoes lasted for over an hour. Over an hour. Now, we all know what happens when you knock on something. If it's solid, it tends to be dense and doesn't have that echo effect. And when it's more hollow, you tend to hear that. And we do this all the time to check for things in walls or to check fruit viability and stuff like that. So this is very important to note that NASA has already stated that the moon rings like a bell, and it rang for over an hour after the 1969 Apollo 12 lunar module ascent crashed onto the moon. Now, we're going to get into why that happened. No one understands what the moon really is, why it's there, why it's here, when it got here, and its true full purpose. So we're going to explain and break it down in this video, in this series of videos, and connect all the dots and all the missing history that has been wiped from the history of this planet. Now, one doesn't need to be a rocket scientist to do a general search as to what kind of rocks are hollow, since we know that there is no atmosphere on the moon. There doesn't seem to be water of any significant magnitude or any growth of anything. So let's assume that it's a rock floating in outer space. And according to NASA from 1969 and Apollo 12, it rang hollow for an hour. So let's just do a generic search. What kind of rocks are hollow? And immediately what you're going to find is the primary kind of hollow rock is called a geode. And a geode is a round or egg-shaped rock which has a hollow cavity inside that's lined with crystals. Now, everybody wants to make fun of people that, use crystals for enlightenment or for other purposes. This comes from our ancient history, from our Atlantean history, and a lot of it's been forgotten, and many people just like to hold on to these things without knowing the real true reason why. So these crystals, such as quartz or amethyst, right? And they form when a bubble in volcanic rock or a cavity in sedimentary rock is filled with mineral-rich groundwater over millions and millions of years. Other similar but distinct formations are concretions, which are solid mineral masses that do not have hollow centers. So that's why a geode is very unique and specific to itself. And the crystals that form out of it are also very unique and to themselves. And we want to follow this path of train of thought so I can show you how the crystals in the moon are directly connected to the crystals and the water here on planet Earth. And it is this connection that bonds our planet and the moon, that we now call it, together. So when we think of technology, we always think of that as something that is futuristic, right? That's why it's called modern technology. It seems to be out of the grasp of ancient way of thinking and thought. And it seems to come with us having an understanding of modern science and technology. So let's look into what crystals are good for in technology. And you will find that they are used for many things that we use still today, that are what we consider high technological devices, such as wristwatches, clocks, radios, computers, cell phones, radar, signal generators, oscilloscopes, and the list goes on and on and on. So a crystal oscillator is an electronic oscillator circuit that uses a piezoelectric crystal as a frequency selective element. And this oscillator frequency is often used to keep track of time or storing of information. And I mean, if you think of a quartz wristwatch, That's a very rudimentary use of when we first, as humans, started reusing crystals in technology. And it provides a stable clock signal for digital integrated circuits. Before the quartz being used for this, we had instability in timing. It was not uh, it was not stable. The stability in a quartz frequency is so stable, and it'll be stable for millions of years. And the stabilized frequency for radio transmission, receivers, the most common type of piezoelectric resonator used is quartz crystals, right? So when people go, oh, I'm into quartz, I'm into crystals, and you laugh at them, well, these things have been used for super high technology for ages. The oscillating circuits incorporate them became known as crystal oscillators. However, other piezoelectric materials, including polycrystalline ceramics, are used in similar circuits. Now, these are things that we have since been working on as mankind and developing, and it was first produced in 1918. So, as you can see, this technology is already over 100 years old just here on Earth. A crystal oscillator relies on the slight change in shape of a quartz crystal under an electric field. And we all know that all technology, modern technology, is based around electric field. And most people assumed early on that magnets and magnetic fields would be the end game or end result of where we wanted to take the technology. But in truth, it is the crystals that really are the end goal, the end game of where all of this technology lies. A voltage applied to the electrodes on a piezoelectrical crystal causes it to change shape. When the voltage is removed, the crystal generates a small voltage as its elasticity returns to its original shape. The quartz oscillates at a stable resonant frequency relative to other low oscillators, um, but with a much higher Q factor, lower energy loss on each cycle of oscillation, and higher frequency selectivity than can be reliably achieved with discrete capacitors and inductors. Those things get overheated easily. They tend to blow out. And so crystals seem to form a more reliable source for that. Once a quartz crystal is adjusted to a particular frequency, which is affected by the mass of electrodes attached to the crystal, the orientation of the crystal, temperature, and other factors, it maintains that frequency with super, super high stability. A crystal is a solid in which the constituent atoms, molecules, or ions are packed in a regularly ordered, repeating pattern extending in all three spatial dimensions. And almost any object made of an elastic material could be used like a crystal with appropriate transducers, since all objects have natural resonant frequencies of vibration. And that's key and that's important. For example, steel is very elastic and has a high speed of sound. It was often used in mechanical filters before quartz was figured out that it could be used better. The resonant frequency depends on size, shape, elasticity, and the speed of sound in the material. High frequency crystals are typically cut in the shape of a simple rectangle or circular disc. There is your pyramid and there is your moon images. Low frequency crystals, such as those used in digital watches, are typically cut in the shape of a tuning fork. And for applications not needing very precise timing, a low-cost ceramic resonator is often used in the place of a quartz crystal. Now, we as humans have figured out how to use crystals as a data storage device, and you can look this up. It's 5D optical data storage, and the 5D optical data storage is an experimental nanostructured glass or crystal for permanently recording digital data using a femtosecond laser writing process. It is also branded as Superman memory crystal in reference to the Kryptonian memory crystals from the Superman franchise. So if you remember the Superman movie where he goes up north and he goes into this crystal palace where all of the history of his home planet was stored, that's exactly the Atlantean model of the supercomputer, of which these crystals are retaining all of the memory of what is now, was, and what will be. Right? It's a huge computer storage system for all eternity in reference to that. And these disks using this technology could be capable of storing up to 360 terabytes worth of data, right? And that's at the largest size of 12 centimeter disk for billions of years, billions with a B. The concept was experimentally demonstrated in 2013 by Hitachi and Microsoft, and they've researched glass-based optical storage techniques, the latter under the name Project Silica, right? Silica for crystals. The five-dimensional descriptor is because, unlike marking only on the surface of a 2D piece of paper or magnetic tape, this method of encoding and storage uses two optical dimensions and three spatial coordinates to write throughout the material, which suggested the name 5D data crystal. No exotic higher dimensional properties are involved. The size, orientation, and three-dimensional position of the nanostructures of the crystal comprise the so-called five dimensions. The concept is to store data optically in a non-photosensitive transparent material such as fused quartz, which has high chemical stability. Recording data using a femtosecond laser was first proposed and demonstrated in 1996. The storage medium consists of fused quartz, where the spatial dimensions, intensity, polarization, and wavelength are used to modulate data. By introducing gold or silver nanoparticles embedded in the material, their plasmonic properties can be exploited. And this is all according to the University of Southampton. The five-dimensional disk have tiny patterns printed on three layers within the disk. Depending on the angle they are viewed from, these patterns can look completely different. This may sound like science fiction, but it's basically a really fancy optical illusion. In this case, the five dimensions inside of the disk are the size and orientation in relation to the three-dimensional position of the nanostructures. The concept of being five-dimensional means that one disk has several different images depending on the angle that one views it from and the magnification of the microscope used to view it. Basically, each disk has multiple layers of micro and macro level images. Recorded data can be read with a combination of an optical microscope and a polarizer. The technique was first demonstrated in 2009 by researchers at the Swinburne University of Technology, and in 2010 by Kazuyuki Hiro's laboratory at the Kyoto University. And it was also developed further by Kazansky's research group at the Optoelectronics Research Center, University of Southampton. Disc recorded from that time have been tested for 3,100 hours at 100 degrees Celsius and still show to work perfectly 10 years later. And so what we're experimenting with now is rudimentary things that we as humans, with our forgotten history, our amnesia of where once we came and how we got here. And so we're trying to recreate this technology, and we've gotten it up to this level. But let's take a step back and look at the moon as a whole as a geode, and each one of those geode crystals compromising gajillions and gajillions and gajillions of terabytes, all within the immense amount of crystals that the moon holds, and all of that connected directly to the earth and storing everything that the earth is doing and everything that is happening on the earth. Now you're asking, well, how does it do that? How does it know how to do that? And what exactly is it storing? Well, that's where the pyramids come into play. So the pyramids are very instrumental in relegating information from the Earth back to the pyramid. And if you guys are curious as to how that happens, well, then check out part 2, because we're going to delve deeper into that in part 2. But in this episode, in this part 1, we want to keep it mainly to the crystals and the moon specifically being a geode. Now, out of all my years studying the moon, reading NASA books, reading technology, and reading science, I have never heard anyone refer to the moon as a geode. Why? Why? It seems the obvious and what it would have to be in order to do what the moon is meant to do. Yes, the moon serves a purpose. It's not just a rock that happened to get caught up in our, our gravity field. It is actually serving a purpose. It is the rudder to this earth. It is guiding it while terraforming it in a designated, planned way. It was pre-thought out. It was pre-planned. It was put into motion, and it is executing its orders by design. And those orders are being relayed to it by, like I said, the ancient pyramids and other ancient structures and rock formations and crystals that have formed in the earth, as well as the water. And we'll get into all of that in part 2 and part 3. So if you're interested in this series of the pyramid moon relation and how it all connects together and how it's all part of the Atlantean design method to terraform planet Earth to make it habitable for humans and for other living species, well, then you'll want to continue listening to this pyramid moon series that I'm putting together. And please share it with other people so it can spread, because this is groundbreaking science that no one else has. And we tend to put it all together here in a concrete form that is easy to understand and follow, so that others can look into this information and either call it BS or go, you know what, that makes a lot of sense, and we need to start researching that and finding out more details as to how all this works.